Okay, this video is a quick recap on trigonometry for right-angled triangles. And we usually say that we're dealing with SOHCAHTOA. Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. So just for a reminder of what these are, if we have a right-angled triangle and we are given an angle on it, this angle here, no idea if you can actually see that or not. I'll do it in black. This angle here, then the longest side of the triangle, so this is our right angle here, the longest side is our hypotenuse. The side opposite our angle, so at the furthest end, is our opposite. Mathematicians, we shorten everything. The side next to it, so the side that joins it but is not the hypotenuse, is our adjacent. You're not expected to remember the spellings, but you may say C-A-D-G. Start that again. A-D-J. As you can tell, I'm having one of those mornings. You may see A-D-J as the shorthand for adjacent. So it's more likely to show up like that. Or just as the letters. So H, O, and A. If we'd been given the other angle, this one at the top here, if we've been given that, I'm going to just put an X on that. Our hypotenuse stays the same, it's still the longest side, but our opposite and our adjacent are in different locations. So we now have our opposite here and our adjacent here. So it's very important you identify, if you have a right-angled triangle, which side is the hypotenuse, which angle you're working with, and whether you're dealing with the opposite or the adjacent to that angle. And it will depend on that angle which way you're working. Okay. So this is where I regret putting things away. Don't know where I've put my cloth. Right. Okay. So in short, SOHCAHTOA stands for sine. So that's sine of your angle. So I'm going to use the theta symbol for angle. Is your opposite divided by your hypotenuse. Cosine of your angle is your adjacent divided by your hypotenuse. Tangent doesn't use your hypotenuse at all. Tangent of your angle is your opposite divided by your adjacent. This is where our SOHCAHTOA comes from. Sine, opposite, hypotenuse, cosine, adjacent, hypotenuse, tangent, opposite, adjacent. Now, hopefully you've had a look through some of the previous materials and you may have seen this set of triangles. These are known as the trigonometry pyramids. These are for right-angled triangles only at this point, remember. Because you don't have a hypotenuse if you don't have a right angle. So what we do when we have a question that involves SOHCAHTOA, so anything that's a right-angled triangle, and they do come up on the Nat 5 exam sometimes, what you'll do is identify what it is you're looking for and you'll take your equation from there. These pyramids make it easier to go straight to the equation you want to work with. So if you're given a triangle, I thought I'd done that as a right angle. Didn't do a very good job of cutting that one. That one's a better one. Hypotenuse is a bit wonky, but never mind. Right, so if you're given a triangle and you're going to work with this, and usually what they do is it's something to do with scale factor, and you'll have like a line coming down here and it'll show you that it's right angled, and they'll give you something that they want on it. You may require to work out missing sides or missing angles. We've got to identify, first of all, are you dealing with sine, cosine, or tangent? Now remember, it's only valid when there's a right angle involved. So if we had, for example, this angle here, and we had this side and this side, we will be dealing with no hypotenuse, because that's the hypotenuse, so that's tangent. If we were to find the angle and we'd been given the two sides, we would cover over the angle bit. So tan of our angle is going to be opposite divided by adjacent, and you would work that sum out. If you were looking for the x in this case, which is opposite, it's the furthest away from our angle, so it's opposite, you would cover over the opposite, and you would have tan of your angle times your adjacent would give you your opposite. If you're looking for the adjacent, so remember that's the one that's next to your angle, that would be cover over the adjacent, and you have opposite divided by tan of your angle. So if it's the letter that's on the top, then it's being divided by the one that's on the bottom. Remember, that's sine, cosine, and tangent of your angle. It's not the angle number itself, it's the sine, cosine, or tangent of the angle. So if you're looking for the angle, you then need to take the extra step. If you were doing sine of this angle, for example, and we knew the hypotenuse, or we were given information on it, it would be opposite divided by hypotenuse would give us what sine of the angle is, not what the size of the angle is. You then need to inverse sine. Right. Okay, the sign for inverse sine on your calculator is most likely these, and they are almost always the second function of the sine, cosine, and tangent keys. On your calculator, you may need to hit a second function button. So for example, here I have got a sharp calculator. I have got sine, cosine, and tangent here. I have second function here. If I hit second function, I will get the inverse sine, inverse cos, and inverse tan. Okay. I have a TechSet calculator here. Again, you can see here I've got sine, cosine, and tangent, and I need to press my second function to get the inverse of the sine, the cosine, and the tangent. Sometimes it's mode or inverse or select. It depends on your calculator, and this is why I say you really need to get comfortable with the calculator you will use in the exam itself. Okay, that's it for this video. The next one in the series on trigonometry will be looking at non-right angled triangles.